Hi guys, John the Quant here. Today we're doing an interview question, rather a famous interview question, known as the 100-seat problem. And it goes like this. 100 passengers get on a plane with 100 seats. The first passenger sits at random. Each remaining passenger sits in their assigned seat if it's available, or sits at random otherwise. What's the probability that the last passenger sits in their assigned seat? Let's get started here. So, you've probably noticed that the only number we've got is 100. So we know that 100 is probably important. But if you just jump right into using 100, you're probably going to get overwhelmed. This is a scenario in which it's better to start small and look for patterns that generalize up to bigger numbers. So let's start with 2 passengers. Seat 1, seat 2. Now, the first guy sits at random. So if he sits in his own seat with probability 1/2, then the number 2 guy gets to sit in his seat with probability 1. But if the first guy sits in number 2's seat with probability 1/2, then passenger 2 doesn't get to sit in his own seat. So here we've got the probability that the last passenger sits in their own seat is 1/2. Okay, let's try with 3 passengers now. Now, if passenger 1 sits in his own seat with probability 1/3, then everybody else sits in their seat with probability 1. But if the first guy sits in the second seat, also with probability 1/3, then the next guy sits at random. And what we've really done is we've reduced it so that this is actually exactly the same as the 2-passenger scenario. And we know that the probability in the 2-passenger scenario that the last guy gets his own seat is 1/2. Or the first guy could sit in the last seat with probability 1/3, and there's no way that the last guy gets his own seat, so that's a 0. So here we've ended up with 1/3 plus 1/6 from this, which equals 1/2. Okay. What about with there's 4 passengers? Well, if he sits in his own seat with probability 1/4, then everybody else gets their own seat with probability 1. But if he sits in the second seat, then we've again reduced this to the 3-seat problem. So in that case, the last guy gets his own seat with probability 1/2. Or if the first guy sits in the third seat with probability 1/4, then again, we've reduced it to the 3-seat version. And we know that the last guy gets his seat with probability 1/2. And here, if he sits in the last seat, then the probability is 0. So if we add that up, we've got 1/4 plus 1/8 plus 1/8, which hopefully you guys recognize as 1/4 plus 1/4, which is 1/2. Now, so far we have a pattern where it's 1/2 every time. But we need to know if this generalizes to everything. So let's do one more. 5. So first, if he sits here with probability 1/5, then everybody else gets their seat. And if he sits here, we've reduced it to the 4-seat problem. So that's 1/5 times 1/2. And if he sits here, we've reduced it to the 4-seat problem, so that's another 1/5 times 1/2. And if he sits here, again, 4-seat problem, 1/5 times 1/2. And if he sits here, that's a 0. So now we've got 1/5 plus 1, 2, 3 tenths, which of course is the same as 2 tenths plus 3 tenths, which is 5 tenths, which is 1/2, which we expected. But it's important to look at this, because what you're going to end up with in the general case is 1 over n plus n minus 2 over 2n. And you can go back if you want and check, and everything that we have done follows this pattern. Now let's play with that, add them together. 2n over 2n plus n minus 2 over 2n is 2 plus n minus 2 over 2n. These 2's cancel out to give us n over 2n. And these n's cancel out to give us always 1/2. And that's how you solve the problem.